Hi everyone. This video is the summary of all events occurred in the cardiac cycle, linking the cardiac cycle to the heart pressure and also the electrocardiogram ECG. This is the heart pressure graph showing the pressure of the aorta and then the pressure of the left ventricle and also the pressure of the left atrium. At the bottom, this is the ECG, the electrocardiogram. So now let's start with the first phase in the cardiac cycle, the atrial systole. Atrial systole occurs during this phase, as you can see that this is the first phase of the cardiac cycle, atrial systole. So during the atrial systole, what we can see is that the blood will be pumped from the atrium into the ventricle. So during this time, the atrium is contracting and causing the increase in the pressure of the atrium. So as you can see here, the atrium is under systole. It is contracting. While for ventricle, it is under diastole, means that the ventricle is relaxing at this moment in this segment. So I will highlight that, maybe using the blue color. So I will shade this segment. This is the segment under atrial systole. So during this time, the AV valve will be open. This is when the AV valve will be open because the blood have to be pumped from the atrium into the ventricle. So the blood has to pass through the AV valve. So in that case, yes, the bicuspid and tricuspid valve has to open to allow the blood to move into the ventricle. While at the same time, the semilunar valve is closed during this time. It is closed because in this phase, the ventricle is still under relaxation. So that's why, yeah, the semilunar valve has to remain closed in order to prevent the backflow of the blood from the aorta. Well, for the impulse, during this phase, what we can see is that there will be two parts that we need to take note, yeah, for the impulse. The first part is during this phase, you will see firstly a P wave. A P wave will indicate atrial depolarization. So meaning that at this point, at the P wave, this is when the SA node, the sinoatrial node, is generating the impulse. And then the next thing that we need to take note would be this PR segment, the PR segment. PR segment actually indicate there's a delay at the AV node. So this delay of the impulse at the AV node is very important because when the P wave occurs, atrial depolarization occurs, meaning that the sinoatrial node is generating the impulse and causing the right atrium to contract. But the problem is the left atrium will need some time to receive the impulse. So in order for the impulse to travel to the left atrium and causing the left atrium to complete their contraction, we need to delay. We will need to delay, yeah, the impulse at the AV node. So this is very important because so that the left atrium and the left ventricle won't contract at the same time. So that's all for the first phase, atrial systole. Then next, we will look into the second phase. In second phase, that would be the ventricular systole. Ventricular systole. In fact, ventricular systole will be covering from here until this one. Yes, the one that I shaded with the red color here. The whole ventricular systole should cover this whole segment. Yeah? But over here, we will separate the ventricular systole into two segments, into two phases. Yeah? So the first phase is the one that I will shade in blue color. And this is the one that we will discuss here. A ventricular systole will have two phases. The first phase is the isovolumetric contraction, and the second phase is the ventricular ejection. So now, what we shade here is actually the first phase of the ventricular systole, that is the isovolumetric contraction. During this phase, the ventricle will start to contract. So the contraction of the ventricle will increase the pressure in the ventricle. And during this time, the blood is not being pumped into the aorta yet. So that's why the pressure will increase so much here. So you can see the pressure will increase so much in the ventricle. It increased so much. That's all because the ventricle is contracting, but then this is isovolumetric contraction, not the ejection phase yet. So the blood is not being pumped into the aorta yet. And this result in the increase in the pressure in the ventricle. So during this time, the atrium has started to relax. So that's why the atrium has started the diastole phase. Atrium, starting from here, it will be keep on undergo the diastole until the next P wave. So the atrium will be diastole, but the ventricle has now become systole. The ventricle has now become systole. So during this time, AV valve, the bicuspid and tricuspid valve and the left and right side, it is going to close. So that's why at this point, this is the point where the AV valve will close. This is important. Why? Because the closing of the AV valve is to prevent the backflow of the blood from the ventricle back into the atrium. While at the same time, the semilunar valve is still remain closed. The semilunar valve is still remain closed. So the semilunar valve will remain closed for this whole period of time. It will be open at this point when it entering the ventricular ejection phase. But during the isovolumetric contraction phase, the semilunar valve is closed. Next, we'll look at the impulse. So during this time, the impulse will show the QRS complex in the ECG. That is the QRS complex in the ECG. So QRS complex in the ECG will indicate that the ventricular depolarization has started. So the ventricular depolarization will start at the apex of the heart. And then only then it will be propagated along the whole, the Purkinje fiber to cause the contraction of the whole ventricle. At the same time, atrial repolarization will occur at the same point here as well. It's just that we won't see any wave here. We won't see any small fluctuation here because these the wave of this atrial repolarization, the impulse of this atrial repolarization has been masked by the QRS complex. So then next, we will move into the next phase, which is still the ventricular systole, but the second phase of the ventricular systole, which is the ventricular ejection phase. In ventricular ejection phase, this is the segment. So I have same thing, shade it with the blue color. At this point, at this period of time, this is when ventricular systole, the second phase, ventricular ejection occurs. Ventricular ejection means that the blood will be pumped from the ventricle into the aorta or the pulmonary artery. So that is why you can see that the pressure, let me clean this a bit. You can see here the pressure of the aorta will increase together with the ventricle. The reason is because the aorta is also receiving the high pressure blood from the ventricle. So that's why the pressure of the aorta also increase at starting from this point. During this time, the atrium is still undergoing diastole. Ventricle is still under systole. And AV valve will remain closed at this point. AV valve after this point, it will remain closed until this point. While for semilunar valve will now be open starting at this point. Why the semilunar valve will open at this point? That is because the blood from the ventricle will be pumped into the aorta. So in order for the blood to go from the ventricle into the aorta, it has to pass through the semilunar valve. So that's why the semilunar valve has to be open. Then only then the blood can move from ventricle into the aorta. How about the impulse? During this time, during this ventricular ejection, it will be considered as the ST segment. ST segment. So ST segment indicate that the ventricular depolarization is completed. So that means that the impulse has now propagated or spread through the Purkinje fiber to the whole ventricle already. So the ventricle has finished the contraction. Then next, we will move on to the diastole. So for diastole, it can be separated into early diastole and also mid to late diastole. Diastole is a long phase, so that's why there are quite many events occurs here. So now we will look at the early diastole first. That means the starting point of the diastole, which is this period of time. So let me shade it with the blue color. During this phase, this is considered as early diastole, or we can call it as isovolumetric relaxation. During this time, the ventricle will start to relax, and relaxation of the ventricle is going to cause the blood in the aorta to fall back. But this backflow of the blood will be blocked by the closing of the semilunar valve. So that's why in the graph here, you can see at this point and also at this point. This is the two important points. So starting at this point, this is when the pressure of the ventricle will drop a lot, but the pressure in the aorta will remain. So why this happened? Well, this is all because the ventricle now, starting from this point, will be relaxing. So when the ventricle relax, it will cause the drop, a very fast drop in the pressure of the ventricle. So the blood in the aorta will tend to fall back into the ventricle. But this backflow of the blood from the aorta into the ventricle will be prevented. So that's why the pressure in the aorta don't drop together with the ventricle. So what actually stopped the backflow? Well, the backflow is stopped by the semilunar valve. So the semilunar valve will be closed at this point in order to stop the backflow of the blood. So for the atrium, at this point, it is still under diastole, while ventricle will change from systole to diastole. For AV valve will remain closed at this point because it will only start to open after this. While for semilunar valve, it will have to close. So semilunar valve have to close to prevent the backflow of the blood from the aorta into the ventricle. For the impulse, you can see that this is where the end of T wave occurs, because end of T wave actually indicate the ventricular repolarization begins at the apex of the heart. So that means that this is the point where the ventricle start to relax. Then next, we will look at the last phase of the cardiac cycle, which is the mid to late diastole. Mid to late diastole will be starting from this period of time until here, until the next P wave. So let me shade it with blue color. So during the mid to late diastole, the blood will flow passively from the atrium into the ventricle. So at this point, both the atrium and also the ventricle are relaxed. So you can see that the atrium is at the diastole phase. Ventricle is also at the ventricle phase. The ventricle is also at the diastole phase. At this point, the AV valve will open. It will start to open. Why? Well, you can see it in the graph here. Starting from this point, this is when the ventricle pressure will be dropping, and drop below the pressure of the atrium. The pressure of the atrium at this point, this is the starting point where the pressure of the atrium is higher than the ventricle. So at this point, this will also means that the atrium is having higher pressure than ventricle, allowing the passive flow of the blood from the atrium into the ventricle. It is a passive flow, so please remember that it is a passive flow. So meaning that it is not causing any contraction yet. This is just the passive flow of the blood from the atrium into the ventricle. So in order for the blood to flow from atrium into the ventricle, the AV valve has to open. So that's why AV valve will start to open at this point. At the same time, the semilunar valve has to be closed because the ventricle is still relaxing. So it has to be closed to prevent the backflow of the blood from the aorta. So this whole phase is considered as mid to late diastole. And the major thing that occurs here would be the ventricular filling. That means the filling of the blood into the ventricle from the atrium. For the impulse, we will only see the flat line after the T wave. This flat line after the T wave will indicate the ventricular repolarization is completed. So meaning that the ventricle is now at the relaxed state. So the whole cardiac cycle will begin again, will restart again when there's another P wave. And that will be starting the whole process, the whole event again and again. With that, that's all for my summary. Hopefully this video helps to clarify your confusion in the cardiac cycle.